Good morning, everybody. Yep, I'm Shellie Habel. I'm a coastal geologist and hydrologist with Chip Fletcher's Climate Resilience Collaborative, as well as Sea Grant. And what I mainly look at are inland sources of flooding from sea level rise. And so the component I'll talk about today is groundwater and groundwater inundation. Okay, so a few things happen when sea level rises with groundwater. One is the water table rises. And so that area between the surface of the water table and the ground surface, it gets narrower. And that's important because that's where a lot of our underground critical infrastructure resides. And another thing that happens is the transition, oh no. So the transition zone between saltwater and freshwater moves inland. And so what that looks like, if you're a piece of underground infrastructure, is that water that becomes inundating becomes saltier and saltier and more corrosive. And then another thing that happens is that in really low-lying locations, groundwater can actually emerge from the ground surface, and that causes damage to surface infrastructure. And that water isn't exactly clean in urban areas, and so that can create a potential health concern. And so this is our natural laboratory. This is the Honolulu area, which is both one of the main economic engines for the state, as well as being located in one of the most low-lying regions of the state. So great combination. So we're actually starting to see all three of those groundwater-related impacts in this area. So our Honolulu tide gauge shows that over the last 100 years, sea level has risen by about ½ a foot. And we're already seeing the impacts in terms of shallowing groundwater and saltier groundwater. So up in the left-hand corner is me taking a measurement of the salinity of emergent groundwater in a basement in Waikiki. And what I'm finding is water that's almost as salty as full ocean water. And so again, really corrosive. And here's an image showing groundwater emergence at the Honolulu police station. And if you don't know where that's at, it's not exactly coastal. It's about a mile inland. And so that just goes to show that sea level rise flooding isn't just limited to places adjacent to the coastline. It's more of a product of elevation. So the Honolulu area just naturally features really low elevations, and a lot of the area here just naturally was wetlands, which is basically emergent groundwater. So back in the day, developers took dredge spoils and placed a tiny little layer cake of dredge spoils atop these wetlands and constructed very heavily on top of them. And these locations are the places we're starting to see groundwater impacts already. So we've really gotten ourselves into a pickle. But we're not alone in this. Actually, it's something that's pretty widespread, this development on wetlands. So the San Francisco area is actually developed out on filled marshlands. Oh, there we go. Boston as well is built out along marshlands. New York City also. And Tokyo. And actually, we did a simple assessment of functional urban areas featuring elevations low enough that they're likely to be having groundwater impacts already. And we found 1,500 of these locations across the globe. So this is a really widespread problem. All right, so we're not really learning our lesson as a people. And we keep on building in these really low-lying areas. And here in Honolulu, we're doing the same. And so as researchers, we try to get ahead of the problem by doing things like modeling studies, validating our models, performing monitoring of the groundwater, and trying to incorporate our findings as much as possible into tools, policy and planning, and conducting further studies as needed. Oh, doesn't like my slides. There we go. So UH researchers were actually some of the first to identify groundwater inundation as being a sea level rise related coastal hazard. And they used 1D modeling to do this study, and so it had its limitations, but we followed upon that with a 3D numerical study with more robust results. And then we realized that there are a lot of these coastal communities feeling the impacts of emergent groundwater, but not all of these communities have their own hydraulic modeler to make simulations. And so we needed to find a simpler way of identifying hotspots for shallow and emergent groundwater. And so what we did was we compared our more robust modeling results with that of bathtub modeling, which just uses elevation data to identify hotspots, flood hotspots. And this was a really painful study for me because one of these simulations, where's the labels? There we go. One of these simulations took years to develop, and another one took about 20 minutes once we had a good DEM. And so these are actually really powerful results because there's been bathtub modeling that's been done for a lot of coastlines across the world. And so we found that they can use these simulations to have a preliminary look at where groundwater is both shallow and emergent, and how that will evolve as sea level continues to rise. Then we conducted another study showing we overlaid different simulations of various flood components on top of each other and on top of GIS layers characterizing infrastructure. But the most eye-opening thing to come out of this study was that we found that 90% of existing cesspools in our study area are already inundated by groundwater. And so that's drawing a very clear link between untreated sewage and emergent groundwater as flooding. So those are pretty strong words that we felt like we needed to validate. And if you're unfamiliar with what a cesspool is, it's basically a hole in the ground that's lined with cinder block. So this is an image here of an eroded out version of one of these over at Honolulu, just so you can see the structure. So what we did to verify our findings was we teamed up with some of our geochemist friends, and we went out to a location in Mapunapuna where in our simulations it showed that there's emergent groundwater already during high tide. And so what our friends did was they used radon as a tracer to verify that yes, groundwater is a component in these floodwaters, and yes, these puddles do contain human sewage effluent. And so yes, we validated that there is that clear link between the two, and these are issues happening now. So that's bad news, but the good news is that these findings have been used in planning for cesspool conversion. So moving on to our monitoring, we're really excited to work with the Honolulu Board of Water Supply. We've installed a monitoring network throughout this study area. And with that, we've been able to track groundwater levels at various locations. So this is the data shown at the Honolulu Police Station where I showed the image of the basement flooding. So the groundwater elevations are shown in blue, and we can look at how they're influenced by movement of the tide. So you can see that in red here from the Honolulu tide gauge. And rainfall, shown here in cyan from the Honolulu, from the airport. And with this, we can calculate things like tidal lag, which is how fast it takes for that tidal signal to move through the aquifer. Tidal efficiency, which is the amount of that tidal signal that shows up. at these points in the aquifer. And then we can strip the data of the daily tide and look at how groundwater is influenced by longer-term changes in ocean level. And then when we have these rainfall events, we can understand how the groundwater elevation pulses up during these events. And so all of this information is being used to update our models. In terms of tools that we're developing, at the beginning of this year, we put out a review paper that looked through the various impacts that coastal communities are already seeing due to shallow and emergent groundwater, as well as the various management strategies that are being taken in those places. And the things that we mainly looked at were damages to roadway, damages to our underground piping network, and corrosion of our buildings and their foundations. In terms of tools that we're creating here locally, we're continuing to use our more robust modeling methodology to look at locations with emergent groundwater, shown here is in blue, and locations with critically shallow groundwater that have the ability to impact buried infrastructure. And we know this information is really helpful for our local planners, and so we make this data available on our publicly facing website, the SOAS Climate Viewer. We're also working really hard to incorporate our findings into documentation, for example, guidance for planning and permitting decisions, and including our findings and documentations for our state sea level rise viewer, which is there's a legal requirement that this information is used to inform things like environmental assessment permitting, as well as real estate transactions. In terms of future work, we're really excited to be working with the Hawaii Corrosion Lab to understand how these subsurface environments, how they corrode different types of components used in our infrastructure. We're really excited to work with them because they're really talented researchers and very well equipped with their lab towards understanding these issues. And we're also working with the State Department of Health to understand locations where there's been contaminant spills and where those are in low-lying enough areas where groundwater, as it rises with sea level rise, will bring that up into public spaces. So with that, that is your whirlwind tour through what we're doing at CRC in terms of groundwater inundation. I've included a QR code here for our website, so you can check out more about these projects as well as the projects being done by my amazing colleagues. So I'll take any questions if there's time.